Okay, let us start the lecture again. Then for any subset of x we have mu of a. Since fn is measurable, okay, we can apply the measurability of fn here. Mu of a intersection fn plus mu of a intersection fn complement, because fn is measurable, fn belongs to lambda. This thing is greater or equal to, it's greater or equal to, it's greater or equal to mu of a intersection fn plus mu of a intersection e complement. कोई मुझे बताए आप में से? रोल नंबर 40. तो आप में से कोई बताए मुझे ये कैसे ग्रेटर और इक्वल आ जाएगा? बिकॉज हाँ, yes, because this thing actually fn, it is subset of E. Okay, fn is union of n sets, but E is the union of all sets actually, not only n sets. So which means that अगर इसका कॉम्प्लीमेंट हम दोनों साइड से अप्लाई करें ना, so that gives this E complement is subset of fn complement. So which means that E complement is smaller set than fn complement. So that's why measure of fn complement will be greater or equal to measure of E complement. Okay, by monotone property of mu. Now we substitute the value of fn here. Value of fn, what's fn? This is equal to mu of a intersection fn. Fn is actually the union gi, I runs from 1 to n, okay, plus mu of a intersection e complement. These sets GIs, they are measurable and disjoint, है ना? GIs measurable भी है और disjoint भी है. Now we can apply that lemma जो हमने किया है, जिसका हमने लास्ट में स्पेशल केस किया था जहाँ पर हमने a को x लिया था. Okay, we can apply that lemma to this thing. It's equal to summation, जिसको हमने इंडक्शन से प्रूव किया था. Summation I runs from 1 to n mu of a intersection GI plus mu of a intersection E complement. So this is true for all n greater or equal to 1. Okay, so letting n approaching to infinity, we get summation I runs from 1 to infinity, or you can say summation n runs from 1 to infinity. Letting n approaches to infinity, we get और इसमें जो है ना, जो लास्ट इक्वेशन आपने ली है उसको अगर आप रीजन दोगे, बिकॉज GIs आर मेजरेबल एंड डिसजॉइंट, बिकॉज GIs आर मेजरेबल एंड डिसजॉइंट, वो आप इसमें रीजन लिख दीजिए. Letting n approach to infinity, then we get this thing, we get mu of a is greater or equal to summation n runs from 1 to infinity mu of a intersection gn plus mu of a intersection E कॉम्पोनेंट. मुझे एक्चुअली E को प्रूव करना है मेजरेबल, तो यहाँ पर मुझे किसी तरह से म्यू ऑफ A इंटर से E चाहिए इस सम की जगह पर. But we can apply the sigma sub additive property. This is greater or equal to this thing, it's greater or equal to mu of union n runs from 1 to infinity A intersection Gn plus mu of A intersection E complement. Okay, mu of the union है ना, less or equal to summation by sigma sub additive property, of mu. Okay, this thing, it's equal to mu of A intersection union Gn and runs from 1 to infinity plus mu of A intersection E complement, and that's equal to mu of A intersection E plus mu of A intersection E complement. So thus we have mu of A. यहाँ last step आप ऐसा लिख सकते हो, mu of A is greater or equal to this. So which proves that E is measurable, क्योंकि वो रिवर्स इनइक्वालिटी आपको मिल गई ना, वो दूसरी इनइक्वालिटी तो ट्रिवियल है, दैट्स वो तो हमेशा आपके पास होती है, mu of A लेस और इक्वल टू mu of A intersection E plus mu of A intersection E complement. So which means that E belongs to lambda. E belongs to lambda. Thus lambda is closed under countable union. And under countable intersection भी होगा ही closed, because it's closed under complementation, है ना. Thus lambda is closed. Thus lambda is closed under countable union. Since lambda is closed under complementation, therefore this lambda is also closed under countable intersection. It's also closed under countable intersection. So next theorem, which is very important, that I have already told you. And the statement is, let mu be an outer measure. Power stuff x to 0 to infinity be an outer measure. Then this triplet, which is consisting of x, lambda and mu, is a major space. मेजर स्पेस का मतलब क्या है? ये जो लैम्डा है ना, ये समीरिंग होना चाहिए. इट्स ए समीरिंग, क्योंकि हमने प्रूव किया ये सिग्मा अलजेब्रा है. और ये जो म्यू है ना, म्यू जब हम इस पर रेस्ट्रिक्ट करेंगे, इट शुड बी मेजर. म्यू मेजर होना चाहिए लैम्डा पर. म्यू आउटर मेजर है, but when we restricted it to lambda, we will show that it's a measure. Mu is a measure. Okay. It's very simple. Proof. We show that mu from lambda to 0 to infinity is a measure, so clearly by definition of mu, by definition of outer measure, mu of the empty set is 0. Now let's take any disjoint sequence in lambda. Now let En be any disjoint, so you can say in lambda, then this union En runs from 1 to infinity, it's also in lambda. ये हमने भी प्रूव किया ना, lambda is closed under countable union. We show that, हमें प्रूव करनी है एक्चुअली वो एडिटिव प्रॉपर्टी है ना, mu is a measure. We show that this mu of this union En runs from 1 to infinity, it's equal to summation mu of En runs from 1. ये हमें प्रूव करना है. फाइनाइट के केस में है तो इक्वल टू, मगर इसको हम कहते हैं फाइनाइट एडिटिव. That is, we show that mu is sigma additive. That is, mu is sigma additive. Mu is sigma additive. Mu is sigma additive. Okay, we have this inequality. We have mu of union En runs from 1 to infinity. Mu is outer measure, so outer measure is always sigma sub additive, so it's less or equal to this thing. Because mu is sigma sub additive. Okay, अब हमें रिवर्स इनइक्वालिटी चाहिए. नाउ फॉर एनी n greater or equal to 1, we have, आपके पास ये है mu of union ei runs from 1 to n, it's equal to summation I runs from 1 to n. ये प्रॉपर्टी आपके पास है. But this thing, this implies mu of union n runs from 1 to infinity En, which is always greater or equal to mu of the finite union because of monotone property. And okay, it's here n. Here it's n, not infinity. It's n here, finite union. Is which is equal to summation I runs from 1 to n mu of En. आप रीजन देख सकते हैं, because mu is monotone. Because mu is monotone. Because mu is monotone. So this implies this mu of union En n runs from 1 to infinity is less or equal to summation I runs from 1 to n mu of ei. This is true for all n greater or equal to 1. Now letting n approaching to infinity, we get mu of union En. It's here greater or equal to, not less or equal to. It's greater or equal to mu of this En runs from 1 to infinity is greater or equal to summation I runs from 1 to infinity mu of E r. You can write n runs from 1 to infinity. They are one and the same. So combining these two inequalities, combining the above inequalities, we get, combining the above inequalities, we get mu of union En n runs from 1 to infinity is equal to summation n runs from 1 to infinity mu of En. So this proves mu is a measure on lambda. So एक आप नोट लिखिए इस पर. So, okay, let's write down the note. When mu is restricted to lambda, when mu is restricted to lambda is a subset of power stuff x, mu is a function on whole power stuff x. हम इसको restrict कर रहे हैं lambda पर, है ना. तो उस केस में मेजर बनता है. उस केस में इसको हम क्या कहते हैं? It's referred to as it's referred to as the measure induced by induced by the outer measure, because mu is outer measure actually, by the outer measure, outer measure by the outer measure. So next is an exercise for you. Let A, B belongs to lambda. They are measurable sets such that A is subset of B and measure of B is finite. So that means measure of B is also finite, because by monotone property. Then show that measure of the bigger set minus smaller set is equal to the difference of measures, measure of B minus measure of A. Measure of difference is equal to difference of measures. सिंपल है, आपको सिग्मा एडिटिव प्रॉपर्टी यूज करनी है. यहाँ पर जो B है ना, ये होगा A यूनियन B के बराबर. सो मेजर ऑफ B is equal to measure of A union B, but measure of A union B is less or equal to measure of A plus measure of B. Measure of A plus, but you want to find actually difference. What's difference? Measure of A union B is equal to actually this B. Can say this this is set A, this is set B. Okay, this is your B, this is A. So what's this B minus A? This B is equal to actually A union this portion plus this portion, which is B minus A. Okay, and these two things are disjoint now, and they are also measurable, because A is measurable, B is measurable, B minus A is also measurable. So it is the disjoint union of two measurable sets B. So which means that mu of B, which is equal to mu of the disjoint union, which are both measurable sets, and we can apply the finite additive property of measure they are measurable and disjoint, so this thing it's equal to measure of A plus measure of B minus A. अब हम इसको यहाँ ट्रांसफर कर सकते हैं because it is finite. Finiteness हमें यूज कर, because this thing is finite. Mu of A is finite, we can transfer it on this side, so that means mu of B minus A is equal to mu of B minus mu of A. बस आज के लिए इतना ही. If now if you have any